morning, Coryell's class. Today we finished 6.3 and we're finding perimeter and area of things called rectangles, triangles, and parallelograms. Are you ready to talk about this?
Yes.
Perimeter. Perimeter is the distance around what?
The outside of an object.
So if perimeter is the distance around the outside of an object, what is that space inside of an object called?
Area.
It's called what?
Area.
It's called area. It's called area. This is a rectangle right here. These are the numbers that make up the rectangle. What are these numbers that make up, or these measurements that make up a rectangle called?
Base and height.
They are the base and height, but they're actually
Dimensions.
they're the dimensions. So the dimensions would be the base and height, or the 4 and the 2. What is that thing that helps us solve a problem called?
Formula.
Formula. Nice job. We're off to a good start. Everyone's eyes still up on the screen? Here's a formula, actually. It's A equals BH. What does that stand for?
Base times height.
Area equals,
Base times height.
but only when you're talking about these shapes. What are those three shapes we're talking about?
Square, rectangle, and parallelogram.
So the area of a square, rectangle, and a parallelogram is base times height. Sometimes people call the base and the height the what?
Length and width.
Do they mean the same thing?
Yes.
Is this formula gross?
Yes.
Yeah, this is the area formula for a triangle, but we actually adjust it so it looks like this. The area formula for a triangle is almost the exact same as the area formula for a square, rectangle, and parallelogram. The only difference is for a triangle, we divide by 2 because a triangle is half the size of a square, a rectangle, or a parallelogram, right?
Yeah.
Does that make sense?
Yeah.
Cool. What's your label you use for area?
Unit square.
You could write square units, unit squared. You could use this as your square because the exponent means square, right? What's your perimeter label?
Units.
I'm going to skip over letter A because that gives us, it's an example of how to find the area and perimeter of a parallelogram. Actually, I'm not going to skip over. What are these numbers here called? They're the what? Say again? I'm looking for plugins. They're the numbers we plug in to give us the answer, right? On this problem right here, is this considered the height? No, because what is this line? It's a slanted line. Is this considered the height, the part that goes straight up and down?
Yes.
Do we have to use this for our height?
Yes.
And because it's a triangle, we always divide by
2.
to find the area, right?
Yes.
Cool. Parallelograms, we know what they look like?
Yes.
We good with that?
Yes.
Is this right here the height of a parallelogram?
No.
No, that's not the height of a parallelogram because why?
It's slanted.
Is this the height of a parallelogram?
Yes.
What are my plugins for the area of a parallelogram? What were my numbers that I used for plugins?
5 times 7.
5 times 7. Down here, last one. You're given the area, actually. Wow. So this is the parallelogram we're talking about. You're given the area, yes?
Yes.
You're given the base, right?
Yes.
Are you given the height?
No.
What do you think you need to solve? What are you trying to solve for? You're trying to actually figure out the height because the x is the height, right?
Yes.
What strategy did I say is my favorite strategy to use to solve this one?
Yes.
Guess and check. So we plugged in 58.1 for the area. We plugged in 7 for the base. Do we know what the height is?
No.
Can we just take out our calculator and start plugging in numbers until we get to this number?
Yes.
Is that an acceptable strategy if you're stuck on a problem? We good?